Okay, so today we're looking at rational functions with quadratic denominators. So our learning intention is to gain the knowledge in integrating functions containing quadratic denominators. The part for this one, I guess the tricks is to really be able to kind of look at the denominator and determine or classify the type of quadratics. So we have quadratics that can be factorized, right? We have quadratics that can't be reduced or can't be factorized any further. We have quadratics that have radicals in them. And we have quadraticals that contain a linear or quadratic in the numerator and a quadratic on the denominator. So it's important to know our standard integrals, and these are on our formula sheets. And what I kind of wrote it down as they appear on our formula sheet on page 3. Okay, so what happens is that we'll have the derivative on the top, and it's been divided by the original function. And so when we have something like that, the solution is going to be log of the f of x plus c. Otherwise, we can have the derivative over a radical, where we have a squared minus fx all squared, and this is inverse sine. Now, we also have things like tan, inverse tan. Okay. We have something like this, like 1 over a term that's squared plus x squared. Well, that is inverse tan. Sorry, so that's inverse cos, sorry. And then we have this standard one where you have a function to the power of n, you have the derivative on the top, and then you have the function on the bottom. Okay. Let's do some examples. All right. So when we look at something like this where you have a quadratic on the denominator, the first step is to see if you can factorize. So here I have x minus 2 all squared. Okay, that's great because that can be written as x minus 2 to the power of negative 2. Beautiful. That's just that. Okay, so we've got negative 1 over x minus 2 plus c. Okay, you can always double check. If you take the derivative of this, you should get that. Okay. Okay, so this is obviously we have a radical, so we're looking at something like this. Okay. Using my standard integral sheet, I'm looking for something that has a term multiplied by x by another term. So in this situation, I have sine of x. So leave it here. I'm looking at that one. So if we have fx squared is equal to x squared, that means f of x is equal to x, and the derivative of x is equal to 1. Sorry, I lie. That's 2x. Sorry, no. Yeah, that's right. Sorry. That is squared, so I take the square root of that, so it gives me x. The derivative of that is 1, so I do have the derivative on a is 1. So at 1 minus fx all squared. So the solution to this is equal to inverse sine of f of x, which is x plus c. Okay, and that's using our standard integrals. Okay, here we have obviously there's a quadratic on the bottom which can't be further reduced, and we have another quadratic on the top. So the way we're going to do here is we're going to kind of add one, take one. Because what I could do at the top, right, x squared, that 2 I can replace it with plus 1 plus 1. Okay, and I can split that as x squared plus 1 over x squared plus 1, right, plus 1 on x squared plus 1. Yeah, because that's both the same thing. Which is technically the integral of 1 plus x squared plus 1 to the power of negative 1 dx. Okay, well this is just x. Well, that's going to be log of x squared plus 1 plus c. So here we've got the integral of x squared plus 2 over x squared plus 1 dx. So we've got a quadratic divided by another quadratic. Okay, so what I'm going to do is going to kind of do this breaking down. Sorry, I'm not going to add one, take one. I'm going to break down the fraction. And tomorrow we'll learn about doing partial fractions, but here this is not too bad. So we've got, I can write this plus 2 as x squared plus 1 plus 1. All right, and what I can do then is separate this so that I have the integral of x squared plus 1 over x squared plus 1 plus 1 over x squared plus 1. All right, well this just becomes 1 plus 1 over x 1 plus x squared. So the integral of 1 is just x. Now the integral of this is using our standard integrals, right? The derivative of x, if I take the square root of that, it just gives me x, and that's the derivative of 1. So this is actually tan inverse tan of x plus c. Okay. We'll do another example. So we've got integral of x minus 1 all squared over x squared plus 2. So what I'm going to do with this one is I will expand the top. So it gives me x squared minus 2x plus 1 over x squared plus 2 dx. I'm going to do x squared if I did x squared minus 2x, instead of writing that plus 1, I'm going to write plus 2 minus 1. Okay, because plus 2 minus 1 gives me still positive 1 over x squared plus 2. And the reason I want to do that is what I can do is then I can get x squared plus 2 minus 2x plus 1. That plus 1 became because I've got this negative out here. Okay, so that's just really integral of 1 minus 2x plus 1 over x squared plus 2. Okay. Now, if I look at this part, so note that x squared plus 2, the derivative of that is 2x, okay, which is what I have here. Okay, so what I'm going to do is separate this even more. I'm going to get 1 minus 2x over x squared plus 2, right, because I've got that derivative there, plus 1 over x squared plus 2 dx. Well, that's just going to give me x, using the understanding that when the derivative is on top of fx, you're going to get log fx. Okay, and when you have 1 over x squared plus 2, well, okay, it means we're going to have 1 over root 2 inverse tan x over root 2. Plus c. Okay, so what I've done is I've basically expanded it. So I expand, I kind of add, subtract to manipulate the function, but always keeping it the same. So we can take the integral of parts. And here we're using standard integrals. Okay, one more example. Okay, here we have a linear and then we have a quadratic. So what I do here is I look at my denominator and I've got x squared plus 4x plus 5. The derivative is actually 2x plus 4. It's kind of very similar to that. So what we're going to try to do is we're going to go, well, 2x. If I have plus 4, right, I need to actually subtract 3 to get plus 1. Which means I get 2x plus 4 minus the integral of 3. Okay. If I did this, well, remember that this is just the log of the function because the derivative is on the top. Okay. What I can do is I take out the 3 from this side, And I'm going to factorize the bottom because that's really x plus. Oh, what I would actually no. What I want to do is I want to probably take or complete the square. Okay, so, and the reason why I want to complete the square is so I can use my tan. X squared plus 4x, 4 divided by 2 plus 4. Okay. And the reason I have 4, so I can split that to be 4 plus 1 making 5. Okay. And so what that actually means, that's actually quite nice. So we get this x plus 2 all squared plus 1. And now using the our tan, okay, so in this situation, our a is still 1. Yeah, our a is 1. And our f of x all squared is x plus 2, so that's just going to be x plus 2. And then plus c. Okay, good luck, have a go.